order list that can be automatically connected to the industry mode, so you can have prices and all of this, which is also really good. Like I said before, to work inside of your project group, so actually one tool for everything, even for your purchasing department. And now we will come here down and click in the project view. This is actually the one that I like the most, because here in the project view you can actually see the structure of your project. So let's start with this project. If I may, I'm gonna name it Gerhard as for now. Okay, and we have basically just a control panel as what we're working for. Good. Then as you can see here, we will have new device, and I can click on it directly. I can have also a group of devices when I want, depending how the structure of the project when I mention it. And if it's okay with you, Gary, I will now start with the motor starters that we have. So to select and dimension this motor starter, we go directly to here, the industrial controls that you can click. You will go directly to the load feeder configurator plus IEC that we have right here. And as soon as it opens, you see that you have the electrical basic design. So as you were mentioning, and you can see here in the sketch, we're working with 400 volts, 50 hertz. I think the system configuration, it's okay to have TNS. If you want to edit it anytime, you can click here in the edition mode and you'll be able to change it. As for now, we will work with type of load as motors, as you can see here. And basically, let's start with the first one. So the first motor we have in the sketch right now, it's a 5 kilowatt motor. We go with a 5.5, of course, because we have to go over it. And as you can see here, the rated current, it's automatically calculated because of the standards that we have. This tool, as you remember, it's called the IEC one. So this is based in the IEC standards, okay? Cable length is really important because of the calculation of the short circuit current rating that we must have here. So it's 25, the one you send, which is a really good thing that we have these distances. Like we were mentioning, we don't have this problem anymore. And you will be able also to mention the manufacturer or the type of load if you want to. And down here you have also the possibility to let's say to select the cable characteristics outside of the cabinet. Okay. As soon as you have this one, really easy, you go here to go to control devices, and when you click on it, you'll be prompted to this screen right here. You see here we have in the right hand side basically a one-line diagram of what we're going to have of the solution. So in this sketch we have exactly a direct starter with overload protection integrated in the circuit breaker or motor starter protector. Coordination type, we'll leave it as 1 since this is only the basic design that we're working on. Supply voltage, we keep it as 24 volts DC and a class overload protection or tripping class as a 10. Okay, good. Then once we have all of this checked out, you come here and calculate directly. As you will see, of course, there's always a disclaimer of liability of the calculation that this does. And when you accept it, you have directly the calculation and the selection, dimensioning basically, of our direct starter. You see here that you have the references or MLFBs of the motor circuit breaker, the motor starter protector, the contactor, and you also have the dimensioning of the cables. Good. This is done taking into account the IEC standard. Good thing that you have here also, you will have the possibility to go to information, and when you go to information, it talks to you actually about how the calculation is done according to IEC 6204-1 and the assumptions that were made and how everything is calculated for this matter. Okay, this is really good because you can also have it in your documentation at the end. Good, so we have the first starter or the first load done. So now we can go again back here to new device if you follow my mouse, and then we can go again to industrial controls, or if I may, the easier way also, you can come here back and you directly come and just copy the load feeder that you have, and then you paste it again with a Control-C, Control-V thing that you can see here. So basically now we have a copy of the load feeder. Now let's call this one load feeder 2, and we will just mention it like this. And as soon as we have the names, we can go directly to the electrical load, same as we did before, but this time now we change this one from a 5.5 to a 7.5 kilowatt. That's the one we have. And as you can see here, of course, you get all of these warning messages, but of course it's because this load or the project, let's say, it's not completed. That's why you have everything. You have to dimension it again. So we go again to control devices down here. And once again, everything gets popped up. I think the distances are the same. We use the same supply of the control voltage, the same triple class. As soon as you click calculate, you get the dimensioning directly. So now we have here a new motor starter circuit breaker, motor starter protector, a contactor, and once again the dimensioning of the cables. Okay, which is really good. So we have now load feeder 2. Let's go to load feeder 3. It's actually the same one, but with a 3 kilowatt motor. So let me just go in the first way that we did it. We go to industrial controls, wiki clear in load configurator plus, and here we can start over with 3 kilowatt motor, 25 meters. It's the one. We go again to control devices, and of course we just click in calculate now, since this is the basic dimensioning that we have and data that we have from your sketch. You see, as soon as I calculate everything and there's nothing, all the warning messages are gone, and you can start with this one directly. So this load feeder will be load feeder 3, actually the one we just did. Okay, good. Are there any questions right now, Gary, or doubts from this?
No questions so far, Jorge, but I have to say I'm very impressed about this new tool and what it takes into account. I mean, beside the fact that it's very helpful for the product selection and configuration, it also takes into account all those IEC standard requirements, for instance, like the short circuit current calculation, the dimensioning of the cables and wires, the ambient temperature in the cabinet, stuff like this. I have to tell you, this caused a lot of headache in our electrical engineering department, and I'm very confident that they will be happy to see this new tool and all its features it includes. And beyond this, I'm sure it will speed up tremendously our engineering process and the efficiency, and it has also an impact on the fault-free dimensioning and engineering.
Okay then, just let me go over here and just close these load feeders that we have done so we can have a better view of the project, and let's continue. Now for the fourth motor, or the fourth load that we have here, we have a soft starter. When we click in new device, we come right here into industrial controls again, and here you can easily select the soft starter Sirius 3RW menu. Here you can easily select the soft starter. As you can see, we have the complete Siemens portfolio here. And of course, when you know the portfolio, it will be easier. So let's imagine that you have a standard application and we want to use the 3RW52 here. As you can see, a window pops up, and here actually I want to recommend you something. If you don't know really well the portfolio of the soft starters of Siemens, and also you may be working with a non-standard application, maybe you have a really heavy start, or you have different types of you want to stop, or maybe you have different application like a pump blockage or something like this, then I will recommend you to use first the simulation tool for soft starters, where you can dimension the soft starter, and then you can bring the selection that this tool did directly here. Because also the other thing that the simulation tool does is it gives you the complete combination or tested combination that you can use. It's under the 60947 standard. Okay, but let's continue with this. Like I was saying, maybe you're using actually a standard application, then you can easily go here to line voltage as a 400 volts that we're using. The connection method will be standard because we're not using inside the delta, and we are starting basically a motor of, like we were saying, 10 kilowatt, but we go here for 11 kilowatt. That gives us 25 amperes in operating current. The voltage range, we'll keep it as up to 480 volts, and the version we will have an analog input output version as for now. The control for this soft starter will be again 24 volts DC to keep everything in the same power supply, let's say, for the control part. In the load side, let's say like this, and it depends whether you like spring-loaded or screw-type terminals. As for now, we'll keep it as screw-type terminals. Then we have the selection here in a really easy way, and as I was saying, here you will have the soft starter, and now it's included in your project. Okay, now the second stage for this will be the selection of the breaker of the MSP that we actually want to use here. So in a really easy way, we come again to a new device, and we come directly to industrial controls, because we're talking about 25 amperes as we've seen. We go directly to a motor circuit breaker up to 100 amps, And again, we make the selections. So actually we want to protect a motor, but we are using also this soft starter, so we can also use starter combination. The operating power of this will be 11 kilowatt, as we remember, the one we used. So the operating current is basically 25 amps. And we have a short circuit breaking capacity. As for now, we keep it as a standard 65 kiloamps. Okay, as you can see here, you can also add up instantaneous contacts. As for now, we will keep just the circuit breaker. You double click on it and automatically it's again added here into your project. Good thing that you have to realize here is if in some time you actually need an auxiliary switch, for example, you can click here in the articles that you see in my right hand side, and you can select whether you want it to be laterally mounted or front mounted. And when you click there, you get prompted in the menu to select this. Let's imagine that we need one open and one closed transfer switch. It comes here, and again, it's added into the project. Okay, good. Are there any questions about the soft starter, how you place it and how to select it from here?
Good to know, to have an alternative to the soft starter selection tool. You know, we used it quite a bit for specific application and to have a very precise sizing and configuration of the soft starter for non-standard, very heavy-duty applications. But now this other option, this alternative, allows us to speed up the soft starter product selection and configuration.
Great. So basically now for the BFD, you come here to new device, but instead into going into inducer controls, you go here to drive technology. And actually you can see here that maybe you know the tool Sizer. The Sizer has been integrated in the TIA selection tool. And here your mechanical design people can actually design the complete axis from the type of load, the motor or gear motor, if anything they want to work with, and at the end the BFD. Okay, as for now we will basically cover the frequency converter to add it to the project. And when this pops up, we come here to configure and we start the DT configurator. This tool will be basically an easy to select type. We have basically a moving load, and we will have basically a continuous motion with a basic performance application as for now that we're using as a conveyor belt. We know we're working with 3-phase motors with 50 Hertz and with 400 volts. Okay, we're working with 15 kilowatts. Then we know that it's an IEC standard and the installation will be a built-in unit. Yeah, and we can easily now just define the product series, either V20 or G120. If you know them, we go for a V20 as a basic application that we're gonna use now. So we say it's a 15 kilowatt motor. We're not gonna use any filters as for now, and then we just continue to the TIA selection tool, and this will be included now in our project. You see, so everything's here nice and neat. So now actually we need to select the product that's going to protect our Dynamics converter and the load. We can do it with an MSP or with a fuse. It depends on what you want to do. So actually I can come here, copy, and just also then paste it. So we have a copy, as you can see here, of the MSP that we have before. Of course, I'm just going to change it. This is going to be for the BFD. And now that we changed the name, actually, we will now basically change it. So we need to configure the product as a new product. So we add a basic unit. I deleted what we had before, as you can see. And actually, with this one, we know that we have actually 31 amperes. So actually, I need to also take out the operating power that we had selected before. And after I delete this, I can either select it by operating power or by ampere trading. I go for the 15 kilowatt. Remember, we're still using 4 starter combinations. So basically, all of the MSPs that are coming here are only magnetic. So as you can see, it gives us an operating current of 32 amperes. The drive was with 31 amperes, so it's a really good selection that we have done here. And basically now we can end with it and we just close it. So we have now, again, if we want to put any auxiliary switch, either laterally or side mounted or front mounted, you usually have normally open, normally closed, and then you have it. Yeah, as you can see here in the article overview, you will have all the products or the accessories that we're working with in this product. And also, like I said before, if you, for example, come here to auto list, you will find the complete list of products that we are working on and that has been already selected and they mentioned for your product. Okay, yeah, you can actually also change the view that you have right here, and when you select like group hierarchy, you will be prompted directly to the same structure that we have in the project. So it's actually really nice to have when you want to see different type of load feeders, how is everything, and where each product comes to. Let's say like this. Good. Are there any questions now, Gary, about this?
All right, good to know. Let me summarize to make sure I got it. So what we did before with the soft starter, there were also two options, two alternatives, either fast product selection for standard applications or for specific and very precise sizing and selection of the soft starter. I used the soft starter selection tool STS.
Exactly.
Now we use for the drive a very similar approach. There is a fast product selection for the drives. And if I have a specific application with several servos and axes, I can use the sizer.
Exactly.
Okay, thank you. And also I have to say that overview, the order list, helps me also quite a bit to sort things out and to have it at one glance. Yeah, thank you.
Great. So now actually your mechanical design colleague can go here into the tool and he can use the sizer to, let's say, design the complete axis when he has the complete information. Okay. Now if it's okay with you, I would like to go into another device. So I click here and now let's go with the ET200 SP that we have here. So basically we go into IO systems and here we will go with the ET200 SP as IO, CPU and controllers that we will use, and we go directly to configure up here. Yeah, now you will have a really nice rack view when everything is mounted. So for example, let's start directly with the CPUs and we will take a standard CPU. You can either drag it and drop or you can double click on it and it will present you some options if you want some bus adapters and some schematic memory cards. Of course, we need a Profinet adapter as you have mentioned in your sketch. We click here as an OK. Now let's add some digital inputs as standards that we have here. Yeah. Now some digital outputs also as standard that you have. And now let's start directly with the starters. We mentioned in your sketch, as we may see here, you have some motor starters. These are all direct motor starters. So basically we have 1 kilowatt motor. So basically you can use this direct starter here up to 3 amperes, can cover this range. I double click on it. Once again, it helps me with the configuration of the potential group and everything. I just click OK on it because as for now I don't need anything special with it. And it's 3 motors, so actually, like I said, double click on it or drag and drop and they will be placed in the next free space. Good. You see up here we have some messages, warning messages, where you click on them and you see them down here. So actually one of the characteristics and really good things that actually the TIA selection tool has is that it gives you some information and some data whether your project is being compiled well, if it's well built, let's say like this. So if you have any mistakes or warnings, it tells you. For example, here one of the good things, it's telling you there's some EMC conformity that is not going here. Actually, you need to put a reserve module between the outputs and the starters. So basically, actually, you can do it yourself or you can just click here in this gear motor or this gear symbol, and as soon as you click on it, you can have down here, as you can see, an automatic correction. And when you click on it, you see automatically, you can see here in the rack, a reserve module is added automatically. Okay, good. So now we have this. All the good things that you will have basically here is the potential distribution. And here in the potential distribution, you can actually see a really nice wiring diagram of how your electrical engineer must design this and how it can work with this. Good. Now the other thing that I want to show you is actually after we have selected this, we go to networks. You mentioned already Profinet. So basically here, I will just connect the modules where I need. So as you can see, it's a topology view. Of course, we only have one CPU. So basically, if you want to interconnect the switches, you can also do them. and you can start creating by the applying the connector, and once again the tool will help you out defining how the cables and lengths will be. Okay, good. Now I would like to combine actually this one with the 24-volt DC consumer view, because actually here's where everything comes by. So actually you can see what are the internal consumptions that we have. We create basically a 24 volts DC network, yeah, but of course we need to define the power supply. And here the TIA selection tool has a really easy thing that you can come up here and you click new supply or new power supply, and it's created directly. Yeah, you can come here, you connect it to them. Now the power supply actually knows what's the load she has to work with, and you come directly here and double click on it. When you double click on it, basically you have the loads, the diversity factor, whether all the loads are going to be working 100% or not, we have not sure yet. But of course, we have to take into account that you will need 30% more than this. So as you can see, a total load for the C-top power supply right now will be around about 6 amperes. So actually, I will take 2 amperes to have basically 30% more to it. Yeah. Then when we go and click here to a power supply and we click add power supply, all of this data that we have already, we can just start and work it out. So basically we will have a 3-phase AC power supply because we have a 400 volts incoming. We wanted to have a thin rail mounting with a screw type terminal, and for example we can take this one of 20 amps directly here. Yeah, we select the desired power supply and we can easily connect it now as a result, and we up down here apply the selection, and it's been applied, and you see that everything that was marked with an X before, now it's already dimensioned. Okay, so actually we have created now the part of the automation with the ET200SP and also the part of the 24 volts DC.
Well, that was really fast. All the product selection, much faster than doing it with the catalog, and then also the 24 volt DC power consumer view. That's also very helpful. Thanks, Jorge.
Yeah, nice and easy. You see, the other issue is that as you can see here in my project navigation view, I have some blue icons. If I click on it, for example, for the complete project over here, I have some information telling me take into account mounting positions, or 0 bytes are reserved for the status information for the communication when the communication takes place. Let's say response with cyclic and time driven, optimization of station design, for example. So actually, you see, TIA selection tool is also helping you to optimize your engineering. So actually, in the same way that we did before, we can have an automatic correction in all of them. And as you can see, my information messages are down to 3, meaning that this got already corrected. And these that are left here are basically messages for the automation engineer, for your electrical engineer working on the project to take into account some things. Okay, we can close it now. And you see here that you have, like, once again, the portal view, the project view in a really nice way. And back again, when I come here to the order list, I have all what we have just done also included here in a really nice and efficient way. Okay, good. Are there any questions now, Gary, or do you think that I can actually forward you now the project?
Thank you, Jorge, for the compilation of the entire project so far. I have to say I was not aware of all those functionalities, and in particular the configuration tools. But well, it's more than configuration, it's almost engineering, and the compilation afterwards really impressed me. Beyond this, the project view you showed a couple times about the entire project, I think it's gonna really be helpful as well. And you know what, those warning alerts, because every once in a while, of course, no matter how experienced the engineers are, there are sometimes mistakes, but I like the warning alerts, and especially the automatic correction functionality. For instance, for the electromagnetic compatibility, the TIA selection tool has already implemented. That is really good. Totally,
I totally agree with you. That's why this is a really nice tool, and that's why actually, since this is a control panel project you have, I brought it to be a little bit more efficient. So actually, we can work only with one tool, like I told you before.
Awesome. You know what? Please send it over. I'd like to install the tier selection tool as well and open it at my place to have a look at the entire project. And I'd like to come back to you in case I have any questions or changes. Thank you.
Totally. I will send it just to you. And if you have any questions, please come back to me and we can discuss it.
Thanks. Bye, Jorge.
Bye.
All right. I received the project from Jorge via email and I installed the tier selection tool. And now I'd like to have a look at it by myself because I noticed that Jorge configured and engineered the majority of the project. However, the main breaker, the main disconnecting means for the feeder circuit is still missing. So I'd like to give it a try by myself and size the breaker right away. So I click on new device and let's see, there are a bunch of icons here. So I assume it is most probably under energy distribution and measurement since I look for a circuit breaker. All right, and here we go. Here are the molded case circuit breakers of the 3VA series. Let me see what this offers. Okay. Well, device name, molded case circuit breaker 3VA. Let's try to rename this. I'd like to call it the main disconnect feeder circuit. Right, it's for the control panel. And now I go on configure. I need a breaker up to 1000 amp based on IEC. I'll have other options as well, up to 1600 amps and also according IEC and UL for the North American market. But I think I'm good with a breaker between 16 and 1000 amp based on IEC regulations and requirements. All right, what do we have here? I think I have a pretty standard application. I need a main disconnecting means. I take the breaker for standard applications. Okay, take line protection to protect properly the line conductors, the feeder conductors. A breaker with 160 amp is fine, is sufficiently. Okay, I take the lock terminal at front. Number of poles. It's a 3-pole breaker for my TNS power distribution network. The rated current. I take 100 amps. Then 380/415 volts. Breaking capacity 55 kiloamp for ICU and ICS is fine. All right, apparently I'm done with the basic configuration. So now let's have a look at the trip unit. Okay, what do I have here? Thermal magnetic trip unit. I don't need a rotary. No, I do need a rotary switch. Okay, I take the thermal magnetic 220. And that's it. I don't need a display. I go back and continue with the tier selection tool with my entire project. Okay, now as we can see, the breaker is added to the project. If I go to the overview here, amongst all the other configurations Jorge had already done, the breaker here is now also included. But you know what? A couple changes came up just recently. And I'd like to give Jorge a call since the conductor length to one motor has significantly changed, and I'd like to know how this can be modified within the tier selection tool. Beside this, one starter needs to be also changed from a direct starter to a reverse starter, and also one motor power has changed as well and need to be adapted. I think I will give Jorge a call and let's see how he can help me. But before I call him, I'd like to save this project in the cloud to what he mentioned, that we can work on the same project. So save as. Then here I have the 3 options: recent files to open, or save it under the cloud or local. So I save it in the cloud, specify project name. Okay, give it my name. All right, I saved it now in the cloud. I was already logged into the Siemens Industry Mall. Okay, and now I will give Jorge a call and talk about the changes.
Hey, that's my phone again. Ah, it's Gary. Hi, Gerhard. How are you?
Good, Jorge. Hi. How are you?
All good, all good. How did it went with your project? How did it went with TIA selection tool?
Actually, very well, very good. Thanks again for the tutorial, I'd like to say. And you know what? I was even capable to size the main breaker by myself. I just noticed that this needed to be sized, and guess what? I think I figured it out. Maybe we can have a look at it. But beside this, I'd like to discuss a couple changes which came up on request, and I think we need to add this. And I didn't dare to do it by myself. Maybe you can assist me a little bit.
Yeah, sure. Did you send me the project already by email or something like this?
Actually, I saved it in the cloud that we can work jointly through the cloud, through that file on it. So maybe you can open it and we can discuss it right away.
Great. Let me open it. Hold on. Oh, great. Wait. Yeah, I have it. I see that you have added here a 3VA main disconnect breaker.
Yeah, that was the device. Yeah.
Cool. Let me share with you my screen also, and we can go over the changes that you made.
Good.
Good. Then I see that you make a main disconnect. It's a main disconnect 3VA 1110. And if I look at the configuration, I have the complete MLFB here. So I think it's 100 ampere. So yeah, I think it's okay what you did. I see that you also have into account the rotary switch. Great.
Yes, yeah. Yeah.
Great. We can work with this. Yes. But you were mentioning some changes. What happened?
Well, actually 3 major changes. One motor needs to be sized differently concerning the power.
Okay.
At one motor branch, we need to significantly change the conductor lengths, the cable lengths to the motor, and you told me that this really matters.
Yeah, totally. This will change the short circuit current calculation that we have in the starter and the motor. Okay.
Yeah. And one starter for one motor branch needs to be also changed from direct starter to reverse starter. Can you implement this?
Yeah, sure. Is it easy for you to send me the updated sketch, or you want to tell me the changes right now?
I tell you those numbers right away. I have it here.
Okay, just go ahead. So for the first load feeder in the left-hand side, we have a motor load of 5.5 kilowatts. Is this still the same?
No, that's going to be changed from 5.5 kilowatt to 15 kilowatt.
Then let's make the change right now. You come here to mechanical power. You select the 15 kilowatt. And as you see, like I told you before, since we made a change, everything gets with a warning signal. We go again to control devices. Cables here didn't change, right?
No, on that project not. Only the power of the motor. Okay,
good. Other things I think stay the same. I click again calculate, and as you see here, now of course the disclaimer of liability came again. This happens every time you open a project. And as you can see here, we have again the resizing of the starter and also the dimensioning of the cable. Yeah, of course, more power, we need a bigger or larger cable for this type.
Oh, wow, that's it?
Yeah, that's it. Easy, right?
That's simple and that fast.
That's simple and that fast, and you will have the opportunity once again to have the information, everything for the documentation, and also something that I didn't show you before, the calculation behind everything that you have here with the impedances and yeah, basically the type of load and cables you're using.
Awesome. That's very helpful for my technical documentation too.
Great. Good. So I think we have load feeder 1 checked. What's any change with load feeder number 2?
Oh yeah, good point. That's here we have a change since the motor will be placed at a different location. We need to significantly change the cable lengths. So right now it's 25 meter. Yeah. And we need to go up at least 45 meters.
Okay, so let me show you something actually right now. As you can see here, we have the calculation of the cable as it was, 2.5 millimeters, with the calculation of the short circuit current, let's say, generated by the motor and also by the network. So actually, if I go back and change what we have here in distances, you come here to electrical load again, and you say it was 45, right?
At least 45, yeah.
Okay, we change it just here for 45. We don't need to change anything else. Supposing that the cable characteristics outside the cabinet stay the same. So we go to control devices again, and it calculates again. As you see, it's already done. The cable dimensions stay the same, but the short circuit calculation of the electrical load actually changes here.
Oh, interesting. I thought the cable conductor cross-section needs to be adapted too, but apparently it's good also for that cable length. It has only a major impact on the short circuit conditions.
Exactly. It's a really small motor, so that's why your cable dimension doesn't need to change because of the amperage rating here that we have.
Very well. Thank you.
Cool. And for the third motor, what's the change?
We need to change the starter from direct start to a reverse start. The application has changed.
Okay, then that's really easy. You go directly into the control, as you can see here, and you change the starter directly here. So you can have the reversing starter, as you were mentioning. We click on it. Once again, of course, the data that we have calculated goes away. We calculate it again, clicking down here, and done. We have calculated the cables have been dimensioned again, and we have the complete project done. So load feeder 2, load feeder 3, we're good with this.
Okay, I will make sure that next time I don't waste your time. Those changes I could implement it by myself probably, but okay, thanks again for your assistance.
For sure, no worries. I mean, as soon as you get adapted to this nice tool that we have, you will see that it's actually really easy to go over from one load to another, make changes, and actually when you need to calculate something, you will be prompted and advised by the warning signs here besides every product.
Okay, another thing which is really important, we got a little bit under time pressure, and therefore I need for the project calculation, I do need the prices. Can we do this right now? Can you? Is there any option to have a look at the list prices?
Yeah, totally. So basically what I will do right now is I will save it since it's in the cloud. All the modifications we have done, you have it already. Let's say it's a live file that you will be able to have. And when you come back here to all the lists, as you remember, we have the list of products. Here you will be able to see actually all the data of your products as soon as you are logged into in the industry mall. So the first thing you need to do is log into the industry mall, as I will do right now. So now I'm logged in the Siemens Industry Mall, and as you can see here, the unit price appear. So I can have actually a complete price for my project or for your project. Remember, since I had a Colombian user for the industry mall, I see Colombian prices, list prices. When you log in, you will see your net prices in this. So hopefully this will work for you, okay? So actually I hope this actually helps you with the time issue that you're having in the project, and you can easily also connect with your logistics and purchasing department in a more efficient and easier way.
That looks great. Very helpful. Thank you. Thank you. Especially having an overview with the total price. Thanks.
Cool. Then I hope this is good for you, Gary. Like I said, it's already saved in the cloud and you can access it at any time with your project members also.
Yes, that's great. I can share it with the other departments within our company. Thanks again for that overview and for that help.
Cool. Then I hope to talk to you soon, and anything you need, just let me know. Have a good day.
Thank you. You too. Bye-bye. Okay, everybody. That was it concerning the role play. We hope we could give you some insights on how the tier selection tool can be used digitally, collaboratively, and in a very efficient way.
Yeah, totally. We hope that you liked what we have presented today. Of course, it's a really nice tool, cloud-based or local-based. You can work within the same project. It's project-based, so actually everyone in your engineering department can work with this. Not only the electrical engineer, but also the automation engineering, the mechanical designer, and even your sales and your customer can work with the same tool. So basically at the end, you increase and you improve your speed, you become more flexible, your quality is improved, and even like was mentioned by Gerhard, you are at the end more efficient.
Okay, thanks again for listening, and thanks for being here with us for this webinar today. We stay for another couple minutes now here in the chat, Jorge and myself, and we are happy to take your questions.
Yeah, thank you all for joining, and hope to see you and that you can join our complete webinar series that we will have. Have a good day, and please bring your questions. We're here to support you.
Thank you. Have a good one.
Bye-bye.